Alright, today we're going to start talking about transformations. We're actually going to spend 4 days on transformations. Okay? Does that mean that it is difficult? No, it means that it's important. I mean, it could mean it's difficult. Transformations are not difficult. They are important, though. Okay? We end up doing... Remember that paper we did Monday and Tuesday with all the parent functions on it? This one right here? This worksheet we did with all the parent functions on it? Okay? We end up spending a unit on almost all of these parent functions, a whole unit on them. Because that's one of the things that we do is we talk about parent functions. Thank you. Okay? So during each of those units, we're going to talk about transformations of that particular parent function. So if we can get the basis down, or at least start with a good basis right now, the first couple days of school, about transformations, think about, number one, how good our grades are going to be every time we get to transformations. But more importantly, how much our understanding is going to be once we get to transformations in each one of those units. Okay? By the second semester of school, when we get to those transformations, we're just going to be able to fly through the lesson because we already know it. We already get it. We just have to transfer our knowledge from one parent function to another parent function. Okay? So I'm going to talk a little bit about this for just a second. Y equals x squared. What parent function is that? It's a quadratic parent function that makes a parabola, right? Okay? So we're going to have all sorts of things, though. We might have something like that. We might have something like that. Now, understand that both the H and the K are just holding like placeholders right now. Okay? They're representing numbers that we would put in, constant numbers that we would put in. Okay? It might be x squared plus 5 or x squared minus 3. This might be x minus 2 or x plus 1, something like that. So I'm just using H and K as placeholders for right now. Okay? And then we might also have something like this. Okay? These are the 3 general transformations we're going to talk about today. So I want to make sure that you understand what each one of these do. Okay? The K causes a vertical shift. Now, this is something that you talked about in Algebra 1. It's been a while, so we're just kind of easing into it. Okay? We're taking it slow. This one right here, the H, when there's something inside of our function, notice how the K is outside of our function. Notice how the H is inside of our function. Does that make sense? You see the difference between inside and outside? Okay. This is a horizontal shift. Now, horizontal and vertical shifts are something, like I told you a moment ago, that we're going to be studying all year. And the most important thing that I can tell you about this thing is when you write this word, please do not forget your F. That's a whole different word. Okay? And you think it's funny and no one's ever done that before until I'm grading tests and someone has forgotten their F. And then I almost fell out of my chair because I'm laughing. Okay? Without the F, this is a whole different word. Okay? We don't need to say it. It's okay. We all know. Okay? So please remember your F's when we're writing shift. Okay? And also just enunciate the word really well. Because if you say it really fast, it sounds like you're not saying the F. Just for the record. Okay? When you have a multiplier, tell me, is this A inside or outside of the function? Outside, right? Inside would mean it would be somewhere inside the square, right? It's outside the function. So how was this? This was outside of the function and it caused what? A vertical shift. This is going to cause something vertical. And depending on what this number is, it's either going to cause a stretch or a compression, depending on what the number is. What do you think, what number do you think would cause a stretch? Give me an example of a number that you think might cause a stretch. 2? Yes. A 2 would cause a stretch. Can I argue with you just a second? A whole number is 2, 4, 7. A fraction, like 5/4. So a number less than 1. Okay. Perfect. Which one is that one? The stretch or compression? So a number that's greater than 0 and less than 1 will cause a compression. So what's going to cause a stretch? Anything else. A number greater than 1. So I couldn't agree with her when she said anything else, because we're still missing a whole set of numbers, aren't we? Negatives, right? Okay? A negative causes something else. That's exactly right. Okay? A negative causes something else. And let me go ahead and write it this way. Let me write negative x squared. It doesn't matter if there's a number there. It doesn't matter if it's a fraction or a number greater than 1 or anything. But if there's a negative right there, what we say is it reflects over the x-axis. Does that make sense? Okay. So here's number 1. Let me see how adept I can be at using this. Here's number 1 right here. Just sketch it. Just sketch it. If you have your workbook, we're doing the work in the workbook. If you do not have your workbook, sketch this graph on your notebook paper. So the important things are that you get that it's passing through about 8 on the y-axis. And then make sure you have this equation written down. So identify the function family to which f belongs. Which function family does that belong to? Sorry, you're still drawing. Oh, it's my fault. I'll wait. Tell me what family it comes from first. It's linear, right? Does everybody see that? This is a linear parent function. Well, this isn't the linear parent function, but it comes from the family of linear. Okay? Now, compare the graph of f to the graph of its parent function. How is it different from its parent function? Somebody tell me one thing. Would it help for you to see where the parent function is? Isn't that the parent function right there? Y equals x. Can you even see that at all? Now you see why I write on with pen on the projector. Okay? So somebody said it moved up. Did it move up? How many? So are we 7 and we're going to say it moved up, or are we going to use our correct vocabulary? Vertical shift up 8. Yeah. Why can't we just say vertical shift 8? You could go down, couldn't you? Okay? So we have to be very clear. It's a vertical shift, and we're moving up 8. Vertical shift up 8. Is that the only thing it does? So there's 2 things, right? There's a negative, and we know the negative causes a reflection. So that's reflected over the x-axis. And then we've got this fraction, 1/4.
So it's also a compression.
Vertical compression.
And
so what we say is vertical compression by a factor of 1/4. Okay? Vertical compression by a factor of 1/4. because the 1/4 is the multiplier. It's the number in front of the x. Okay? Based on our notes from just a second ago right here, that's our a value. 1/4 is our a value. Okay? Any questions? No, you just say vertical compression by a factor of 1/4. Questions? All right, draw number 2. Just a horizontal line passing through 3 on the y-axis. When you get it drawn, let me know. Got it? Okay, here's number 3. I'm going to put 3 and 4 where you can see them both. Go ahead and get 3 and 4 both drawn. Can you draw those and me ask you a question at the same time? Is there anyone in this room that does not have a book? That did not get a book checked out yesterday? Okay. Would you mind going up to the board and writing 3rd and putting a 1 after it, right below where it says 2nd? I'm having to figure out how many books to order because we're out. So that's part of the reason I'm making sure you have access to the book on the internet today. But I will be making copies of the book for you when you have assignments that I need you to do out of the book. Okay? Do you have 3 and 4 drawn? Not quite? Okay. You can see 5, 6, and 7 kind of-ish at the bottom. So if you want to write down those equations, that would help as well. Is everybody done with 3 and 4? No? Okay. Yes? Okay. 5, 6, or 7. Which one do you want to do together? 5, 6, or 7? 7? Okay. So look at number 7. It says graph the function and its parent. My suggestion to you is that you graph the parent function with a dotted line or with a different color. Okay? What does the parent function of this kind of equation look like?
Like the absolute value question?
Absolutely. What shape is that?
It's just the
It's like, it looks like a V, right? Okay. So 2, 3, 4, 2, 3, 4, 1, 2, 3, 4. So where does it start? At the origin? My parent function starts at the origin, right? That's the bottom of the V. There, there. Up 1 over 1, both directions. In the positive direction though, right? So I'm going to graph my parent function like this. This one in the book says y equals absolute value of x plus 1. So where's it moving compared to its parent? Vertical shift up 1. So we've got to have that written because it does say describe the transformation, right? Vertical. Hey, also guys, this is how you spell vertical. Not V-E-R-T-I-C-L-E. That's what I see a lot. And I have to admit that I laugh sometimes at that. Inside of my head. Inside of my head. Okay. Vertical shift up 1.
y equals x plus 1 is the parent function, right?
Y equals absolute value of x is the parent function. This is our given problem right here. That's a good question. Okay? So, what is this telling me? Vertical shift up 1. What moves up 1? The entire thing, right? This moves up 1, 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 and so on. So that my new function is the same shape as it was before, it's just 1 higher than my parent. Okay? So you have an example of one of the first 4, and you have an example of one of the second 3. Is that good? So you have the rest of the period in here to work on this and get this done. Do you have any questions?
So it's just 1 to 7, right?
Yes, ma'am.